All right, here we go. So this is going to be Clovis High School's review. And this section that we're going to be reviewing is we're going to be reviewing how to simplify expressions, and particularly we're going to be talking about how do you take an expression that is in what we call exponential form, and how do you simplify that expression by first of all changing it into radical form and then going from there and giving us an actual answer. Okay, so before we get started on how to actually do this, let's go ahead and let's just go over some review concepts that you need to know, and some terminology that you're going to hear in this particular lesson, so that when you hear the terminology, you'll know what we're talking about. I can spell terminology. There we go. Okay, so the first thing is we need to understand, what do we mean by an expression that is in exponential form? And once we have an expression that is in exponential form, how do we convert it into an expression that is in what we call radical form? Okay, so that's really the review that we need to go over first. Okay, so exponential form is any expression that has an exponent in it. Okay, so if I say take an x, a variable x, and it doesn't have to be an x, and we'll do one where we have a numeral, and then I give that exponent of, I put an exponent for this x right here, and in these particular problems that we're going to do, the exponents will always be fractions. So if we had x to the 2/3 power there, you can see, and let me zoom this in so you guys can see it a little bit better. Okay, there we go. And so this is what we call exponential form. Now recall, the x is called the base, and the 2/3 is called the exponent. Okay, and what you guys need to know how to do is that you need to know how to take any expression in exponential form and how do you convert it into radical form. Okay, so radical form is any expression that has this symbol in it right here. Some people erroneously or with error call this the square root symbol, and that's like partially true. This right here is actually what is known as the radical symbol. Okay, and then there's a couple major parts too whenever we have an expression in radical form, which means we're going to have the radical symbol. There's two major parts to this expression or this form that we have. The first major part, or one of the two major parts, is whatever is inside the radical symbol. Okay, so usually there's something inside the radical symbol. Sometimes it's a number, sometimes it's a variable, sometimes it's a combination of numbers and variables, but it doesn't really matter what it is right now. But whatever's inside there is what is known as the radicand. Kind of a weird word, but you're going to hear me say that quite a bit. And then also there's going to be a little number right here. Okay, this little number right here, and this is what is known as the index. All right, so if I say start with x to the 2/3 power, which is in exponential form, and then I want to change it into radical form, this is how we are going to do it. You would draw the radical symbol. So we'll go ahead and go like this. Okay, and so you would draw the radical symbol, and whatever is in the denominator of your exponent, which in this case is a 3. Remember, when we have a fraction, we have the numerator and then we have the denominator. Whatever number is in the denominator of your exponent, that will become the index of your radical form. So I have a 3 here in the denominator, so that means that my index is going to be a 3. Okay, then whatever the base is in exponential form, which in this case is an x, that's going to become your radicand. So since this exponential form had a base of x, that means the radicand is going to be an x. And typically you're going to put the radicand in parentheses. And then that radicand is going to have an exponent, and that exponent's going to be whatever your exponential form's numerator exponent is, which you can see is a 2. So this would become a 2 right here. So what that means is that in exponential form, x to the 2/3 power is the exact same equivalent as in radical form. And the way that we would say this is the cube root of x squared. These two expressions are exactly equivalent to one another. That one's in exponential form, that is in radical form. Okay, so let's do a couple just examples of this. Let's do 2 more to make sure we understand. So let's say I have 9 to the power of 4/7. Okay, so that is an exponential form because that is that this has an exponent. The base is 9, the exponent is 4/7 for the exponent, the numerator is 4, the denominator is 7, and what I want to do is I just want to change this into its equivalent radical form. Okay, so how do I do that? Well, I draw the radical symbol. Don't call that a square root symbol, just refer to it as the radical symbol. And then remember, what we're going to do is this. We're going to fill in the index. So the index is going to be whatever number is in the denominator of your exponent. So since I have a 7 in the denominator of my exponent, that tells me that the index in radical form is going to be a 7. Whatever the base is of your exponent form, which in this example is a 9, that becomes your radicand. So your radicand would be a 9, and then your radicand would be to the power of 4. And the reason it's to the power of 4 is because the exponent form's numerator's exponent is 4, so that becomes the exponent for the radicand. So what are we saying here? Once again, we are saying that 9 to the power of 4/7 is equivalent to, and the way that we would say this is, this would be the 7th root of 9 to the 4th power. Okay? All right, one more so you get the example of just how to convert these, and then we'll get into the actual lesson. So let's do one more where I have, let's say I have a parentheses, and I have 5y to the power of, I don't know, let's go 9/2. Okay, so this right here would be considered an exponential form, and it's an exponential form because we have an exponent. So what I want to do is I want to change this to its equivalent radical form. So how do I do that? I draw the radical symbol. Okay, whatever the denominator is of the exponent, which in this case is the 2, that's what you're going to write the index right there. Now, this is an interesting fact. If the index is a 2, you will never see a math book that puts a 2 for the index, okay? So if the index is ever a 2, you just never write it, okay? So if you don't see an index, if you don't see an index, it is a 2, okay? It is a 2. So because the index is going to be a 2 here, I'm not actually going to write the 2. Okay, as math people, as math students, if we don't see an index, we know that that index is a 2. Okay, then I'm going to take the base in exponential form, which is the entire expression 5y, and that's going to become my radicand. And then that radicand is going to be to the power of 9, and the reason why it's to the power of 9 is because in exponential form, my numerator of my exponent is 9. So once again, here's what we are saying. We are saying that 5, the quantity 5y to the power of 9/2, is equivalent, it's the same exact thing as the radical, and the way we would say this, if the index is a 2, we would say the square root of the quantity 5y to the 9th power. Okay? Okay, so that's the first thing that we need to do. So now we need to go into how do we evaluate expressions, okay? So what we're going to do is we're going to do about 4 or 5 examples of how to evaluate expressions, okay? Now, evaluate expressions. Now, if you don't know what the word evaluate means whenever you're in a math setting, the word evaluate means that I want to know what an exact answer is. Whoops, let me pull this down so you guys could actually see what I'm writing about. There we go. Okay, so the word evaluate, once again, means that I want to know what is the exact answer going to be. Okay, so the first example that we're going to do is we're going to evaluate the expression 36 to the power of 3 over 2. Okay, so if you were in a classroom right now, I would ask you a couple questions. The first question would be, is what type of form is this expression in? And you would say, Mr. Tredna, it is in exponential form. Okay, and I would say, what's the base? You would say 36. I would say, what is the exponent? You would say 3 over 2. I would say, what's the numerator of the exponent? You would say 3. I would ask you, what's the denominator of the exponent? You would say 3 over 2. Okay, so when I say evaluate this, I want to know what value does 36 to the 3 over 2 power exactly equal. Okay, here is how you're going to do it. Your first step is you are going to convert this expression, which is in exponential form, you're going to convert it into its equivalent radical form. Okay? So how do I do that? Well, I'm going to have an index. What is my index going to be? Remember, my index is going to be the denominator of my exponent. Okay, so since my denominator is 2, that means my index is going to be a 2. Do I write a 2 when the index is 2? The answer is no. Okay, then I'm going to fill in my radicand. My radicand is going to be my base of my exponential form, which is 36. And then I'm going to put that radicand in parentheses, and then that radicand is going to be to the power of the numerator of the exponent, which is 3. Okay, so the first thing that I do is, when I'm evaluating an expression in exponential form, I first convert it into radical form. Okay, now my next step is, I'm going to do a series of steps to figure out exactly what 36 to the third power with an index of 2 is going to be equal to. Okay, so what I'm going to do is, my first step is, I'm going to take whatever is in the radicand, which is 36, and I'm going to make a factor tree of it, and I'm going to factor tree it down into and I'm gonna factor tree it down until I am left with nothing but prime numbers. Okay, so when we make a factor tree, what times what makes 36? Well, you have a couple options. You could go 2 times 18, you could go 3 times 12, you could go 6 times 6, or you could go 9 times 4. Do not go 1 times 36. Okay, so which option do you want to choose? So I'm going to just choose 9 times 4. And then we're just going to keep factoring each branch of the factor tree until I can't factor in anymore. So what does 9 factor into? Well, that factors into 3 times 3. And we have to stop because you can't factor 3 anymore because there's no factors of 3. Those are prime numbers. So I move over here to this branch. And what does 4 factor into? Well, 4 factors into 2 times 2. Okay, so what does that mean? That means that this radical, if I rewrote it out in what we call its expanded form, 36 would become 3 times 3 times 2 times 2, and then it would still be to the third power. Okay, so what did I do? I just took the radicand, 36, I made a factor tree, and then I rewrote 36 in what we call its expanded factored form. And if you multiplied this back out, 3 times 3 is 9, 9 times 2 is 18, 18 times 2 is 36, this would be equal to 36. Okay? Now, here is where the index is very important. Since the index is a what? Remember, we can't see it, so what does that make the index? It is a 2, okay? And I'll write it here in highlighter, so it's invisible. Highlighter means it's invisible, but you can still see it. What this means is that to simplify this radical, I need to find identical pairs of numbers. Okay, the index of 2 is saying to simplify, you have to have identical pair of numbers, and you could see I have an identical pair of 3's. So what happens when you have an identical pair of 3's inside a radical where the index is 2? It's simple. They cross out, but what they go to the outside and they go to the front of the radical, but they don't go as 9, they don't go as 3 times 3, they go as whatever they are a pair of. So that means a 3 would end up on the outside of the radical there. Okay, and then I keep going. Do I have any other identical pairs of numbers? Yes, I do. I have an identical pair of 2's, so I cross them out, and that means that those also go to the front of the radical as well. So I'm going to have a 2 in the front, I'm going to have a 3 in the front, and if you end up with multiple values, you multiply them together. Okay, so what does this mean? Well, this means that this problem becomes 6, okay? So 36, when you have a index of 2, which we call the square root of 36, just becomes 6. All right, but how many sets of these do I have? Well, I have 3 of them, so that means how many sets of 6 do I have for my answer? I have 3 of them. So my answer would be 6 to the 3rd power. 6 times 6 times 6, that is 216. Okay, so what are we saying in this problem? We are saying that 36 to the power of 3 over 2 is equal to 216. That would be evaluating 36 to the 3 over 2 power. Okay, and this is the process that we're going to go through. All right, let's do another one, number 2. All right, so 343 to the power of 4/3, or to the exponent of 4/3. So this, and I want to evaluate this. So I want to know, what does this equal exactly? Okay, so how do I do that? Well, I'm going to kind of follow the same steps as I did in example number 1. So this is in exponential form. So the first thing that I need to do to evaluate this is I need to convert it into radical form. Okay, so I'm going to draw the radical symbol. What would my index be? My index would be a 3. Why a 3? Because that's the denominator of the exponent over here. What would I put for my radicand? My radicand would be 343. Okay, why? Because whatever is the radicand is the base in exponent when it's in exponential form, and then this 343 would be to the power of 4. So I convert the exponential form into radical form. Okay, and now what I'm going to do is I'm going to go through, once again, a series of steps to simplify, to figure out what this problem actually equals. Okay, so what I do is I take the radicand, which is 343, and I'm going to factor it out. And I'm going to keep factoring. I'm going to basically expand 343 into what we call its prime factorization. So what times what equals 343? Well, 49 times 7 is 343. And I keep factoring until I cannot factor any longer. So 49 could be factored down into 7 and 7. And you can't factor 7's anymore. So when I'm done factoring, I'm left with 7 and 7 and 7. Okay, so what does that mean? It means that when I do the factored expansion of 343, this would become, I would have the radical symbol with an index of 3, but instead of 343, I'm going to write its factored expansion down, which is 7 times 7 times 7. And how many groups of 7 times 7 times 7 do I have? I have 4 of them. Okay, so now I'm ready to simplify this. So here's where the index comes into play. So the index says, since this is a 3, to simplify this expression here, to see what it equals, I need identical triplets of numbers. Okay, the 3 is saying I need identical 3's. And you can see I have 3 identical 7's. So what does that mean? It means I could cross them out, and whatever they are identical of, that goes to the front of the radical symbol. So that would be, so I would just put a 7 there. Don't multiply them together. It's just whatever they're all identical of, it changes to that right there. Okay, so now if you notice, there is nothing left. I should have said this in number 1. So there's nothing left in the radicand. I crossed them all out. So that means when we write out our final answer, the radical symbol is going to completely be dropped from the equation. So what's my answer? Well, I have a 7. The radical symbol gets completely dropped from the answer because all the radicands canceled out, and I have a 4th power. So my answer is 7 to the 4th power. In other words, whatever 7 times 7 times 7 times 7 is, and heck, I don't know what that is, so that would be 49 times 49. I don't have a calculator on me, so I'm going to have to work this out the old-fashioned way. So 49 times 49 is, let's see, that'd be a 1, carry the 8, 9, 8, 36, that'd be 441, put a 0 there, 4 times 9 is 36, carry the 3 now, 4 times 4 is 16, so that's 19, and then we add them up, so we get a 1, a 0, carry that. That'd be a 4, 2,401. Okay, 2,401. So I just evaluated this expression. So what am I saying? I'm saying that 343 to the power, or the exponent of 4/3, when I evaluate it, it is exactly equal to 2,401. All right? Okay, example number 3. Let's do 2 more of these. Okay, and then we'll be done. All right, so number 3, 64 to the power of 1/6 power. Okay, so 64 to the power of 1/6, to the exponent of 1/6. Okay, so once again, I want to evaluate this. So what's my first step to evaluate an expression that's in exponential form? Remember, you change it into radical form. So we draw the radical. The index would be a 6. The radicand would be a 64. And then we would put that in parentheses, and then that would be to the exponent of 1. Now remember, if something's to the exponent of 1, you don't have to write it. So really, I don't need the parentheses here. Okay, so what's my next step now? Well, now I'm going to take my radicand, which is 64, and I'm going to make a factor tree out of 64. So in other words, what times what is equal to 64? And you can choose any 2 numbers that multiply to make 64 that are whole numbers. Okay, don't choose 1 times 64 though, because it'll just be like a repetitive cycle that you'll just have to keep going over and over again. And I'm going to go with 8 times 8. Okay, 8 times 8 becomes 4 and 2. 4 can still be factored down into 2 and 2. So that means I could factor this 8 the same. That's why I chose 8 times 8, so I didn't have to think too hard. And so we have that. So we have 1, 2, 3, 4, 5, 6 2's. So then what I do is I'm going to rewrite this radical. Still going to have an index of 6, but now for the radicand, instead of 64, I'm going to write out its expanded factored form, which is 2 times 2 times 2 times 2 times 2 times 2. Okay? And if we multiplied all these 2's back out, guess what they would equal? If we did it right, they would equal 64. And they do. Take my word for it. Okay, so now I'm ready to actually evaluate and say what this equals. Okay? So here's where my index comes into play. So since my index is a 6, that means I have to find 6 identical numbers to simplify this. 1, 2, 3, 4, 5, 6. You can see I have 6 2's. So then what does that mean? It means I could cross all of these out, and then they go to the front of the radical symbol as just what they're identical as, which would be a 2. Now notice, once again, all the radicands canceled out. So that means my final answer will not have a radical symbol in it. The radical symbol gets canceled out because all the radicands get canceled out. So what's the only thing that I would have in my answer? It would be a 2. Now what's the exponent right here? That's a 1. So technically my answer is 2 to the 1 power, but 2 to the 1 power is just simply equal to 2. Okay, so there's my answer. So what am I saying? I'm saying that when I evaluate 64 to the 1/6 power, that is going to be equal to 2. All right? Okay, last example, number 4. Now, number 4, I'm going to make it look just like number 3, but with one exception. I'm going to throw variables in to the base of the exponent. So instead of just 64 to the 1/6 power, I'm going to make the base 64 m to the 12th power, then to the power of 1/6. Okay, so let's do an example of what do you do when you have to evaluate this expression but it has an exponent involved with it. Okay, all right, so we're going to follow the same process when you have an exponent. So what's my first step? Well, I'm going to convert this exponential form into radical form. So I draw the radical. What would my index be? It would be a 6. What would my radicand be? Remember, my radicand is always the base, and my entire base is 64 m to the 12th power, and then that radicand would be to the power of 1 because the exponent has a numerator 1, but I don't have to put a 1. Okay, now my next step would be I am going to factor the radicand. Now, when I factor the radicand, I'm only going to factor the numerical part of the radicand. I'll show you what to do with the exponents in a second. Now, I don't have to do this 64 again because I just did it up here. So I know that this 64, when I factor it, I'm going to end up with 1, 2, 3, 4, 5, 6 2's, as you can see from down here. Okay, so that means that when I write out my radical in expanded form, I'm still going to have an index of 6, don't forget that, and then I'm going to have my 64 would be 2 times 2 times 2 times 2 times 2, that's 5 of them times 2. Now, watch what I'm going to do with the m to the 12th. I am going to expand m to the 12th. Okay, but I'm going to expand it so I have 6 identical pieces at a time. Okay, so m to the 12th means you have m multiplied by itself 12 times. So really this means you have 12 m's. So m to the 12th can be rewritten in expanded form as m times m times m times m times m times m. That is 6 of them right there. Now, why didn't I write out all 12? Because I'm writing them in identical sets of 6, because my index is 6. Okay, and then I'm going to have m times m times m times m times m times m. So when I want to evaluate this, and I ran out of room, let me pull my paper this way a little bit so you can see it. You can see I have 2 times 2 times 2 times 2 times 2 times 2, which is 64. And then I have m to the 6, and another m to the 6, which means I have m to the 12. Once again, why did I group them in identical pairs of 6? Because my index was 6. Okay, so now I'm looking for identical numbers or variables that are in identical sets of 6, because the index is 6. So here I have identical 2's, 6 of them. So I cross them out, and then the rule is you put them out in the front of the radical. So there's going to be a 2 out there. Okay, now I have identical 6m's, so I'm going to cross those out, and I'm going to move those out in front, so I'm going to have an m, and I'm going to multiply that by 2. So right now I have a 2m. Okay, I have another set of identical 6m's, so I'm going to cross those out, and I'm going to move those out in front too, and I'm going to multiply. So out in front I have a 2, an m, and an m, which is 2m squared. Now notice, is there anything left in any of the radicands, or did everything cross out? Everything crossed out. So if everything crossed out, that means your radical symbol, it gets eliminated from your final answer. So what's your final answer? 2 times m, which is 2m squared. There's your answer. Okay, so when I say take 64m to the 12th power, to the 1/6 power, what does it evaluate to? In other words, what is it equal to? Well, that is equal to 2m to the second power. Okay, all right, there we go. So there'll be a worksheet that will accompany this video. Go ahead and work on it, and best of luck to you guys.